નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Good morning, students. Today we are going to learn Standard 10th Mathematics, Chapter 14, Statistics. So let's start exercise. In question 2, the lifetime in hours of 225 electrical components given here. In this question, lifetime of 225 electrical components given. It is in hours. We have to determine the lifetime of the components. So here you can see the 0 to 20 hours. It is in hours. 0 to 20 hours. There are 10 components. There are 10 components whose lifetime is 0 to 20 hours. Then there are 35 components whose lifetime is 20 to 40 hours. 52 components having lifetime 40 to 60 hours. 61 components having lifetime 60 to 80 hours, and 38 components having lifetime 80 to 100 hours, and 29 components are there having lifetime 100 to 120 hours. So we have to determine the model lifetime of the components. Means highest number of hours, their highest number of components having this lifetime in hours. So first of all we have to go for here for this model lifetime. We have to calculate here frequency, highest frequency. Here you can see the highest frequency is 61. Highest frequency is 61. So the class having this frequency is called model class. So here the model class is 60 to 80. This is the model class, and therefore lower limit of the model class is 60. Then class width, you can see 20 to 40, 40 to 60. So here difference between upper boundary points or lower boundary points 20. So here class length or the class width is 20. Now after this model class, we have to go for the frequency F1, that is the frequency of the model class, and that is 61. Then frequency of the class previous to the model class is 52, and the frequency of the class next to the model class is F2, that is 38. And therefore we can find the mod is equal to lower limit plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 multiplied by class width. Substituting the value here, L is equal to 60 plus F1 is 61 minus F2 is 52 divided by 2 times 61, that is 2 times F1 minus F0, that is 52 minus F2, that is 38, whole multiplied by class width, that is 20. And therefore the mod is equal to here 60 plus, here we will get 61 minus 52, that is 9 divided by 2 into 61, that is 122 minus 52 minus 38. So 122 minus 90, that is 32 multiplied by 20 is 8 4 ja 4 common, so 8 4 ja, here 5 4 ja, and therefore mod is equal to 60 plus 45 divided by 8, and therefore Z is equal to 60 plus, here we can multiply by 8, 125 or we can take that here divide by, so 45 divided by 8, here we will get 5 8 ja 40, then 5 left, so here it is 625, 5.625. So Z, that is mod is equal to 65.625. So here this is the mod 65.625. Here is this hours, 65.625 hours is the lifetime of the components, or we can say the maximum number of components having this lifetime, that is 65.625. Today in exercise 14.2, question number 3. Total monthly household expenditure of 200 families of a village is given here. Here total monthly household expenditure, total 200 families, it is given here. Here you can see the expenditure of 24 families. Monthly expenditure of 24 families is 1000 rupees to 1500 rupees. Same way here for number of families, 200 families, distribution of monthly expenditure. Here maximum 4500 to 5000 rupees monthly expenditure. There are such 7 families. So our question is to find two things. First of all, model monthly expenditure and then mean monthly expenditure. So first of all, let us go for model monthly expenditure. So for model monthly expenditure, we have to calculate, first of all, we have to go for model class. So for model class, you can see here the maximum frequency. So here maximum number of families or maximum frequency. Here there is 40. Maximum number of families, that is maximum frequency 40, and therefore the class of this frequency is called model class. So here the model class is 1500 to 2000. Then therefore the lower limit of this model class is 1500. Is the model class here, lower limit is 1500. It is called the lower limit. Then frequency F1 of this is 40. Then frequency of the previous class, that is 24, and the frequency F2, that means frequency of the class next to this model class is 33. At the same time, the class width, you can see the difference between two consecutive upper limits or lower limits, and that is 500. So this is regarding data. So for this, let us find out the, therefore here we can say here mod is equal to lower limit plus f1 minus f0 divided by 2 times f1 minus f0 minus f2 multiplied by class width. So therefore mod is equal to here lower limit. What is lower limit? 1500 plus here in bracket f1. What is f1? That is frequency here 40 minus f0 is 24 divided by 2 times f1, that is 2 times 40 minus 24 minus f2 is 33 multiplied by class width, and that is 500, and therefore mod is equal to 1500 plus, now 40 minus 24 divided by 2 times 40 minus 24 minus 33. So here we get the calculation. This is 16 divided by here, this is 23 multiplied by 500, and thus we get here mod is equal to 1500 plus 16 by 23 multiplied by 500, that is 8000 by 23, and that is 1500 plus 8000 by 23, that is 347.83, and so our mod is here 1847.83. So this is what, nothing but the mod. Mod means here there are maximum number of families having monthly expenditure 1847.83 rupees. So maximum number of families are having this much expenditure. Okay, now we have to find out mean for this. So for mean, what shall we do? For mean, we have to calculate first of all step deviation. Okay, for step deviation we need to go for assumed mean and class mark. So first of all class mark, and then we'll go for assumed mean. So you can see here 1000 to 1500, and class mark here you can see it will be mid value, that is 1000 plus 1500, that is 2500 divided by 2. So 2500 divided by 2, that is 1250. Is it clear? Then as we know the class width here 500, so plus 500, so 1750, 2250, 2750, 3250, 3750, and 4250, here 4750, here this okay. So now class mark. Now we have to go for the step deviation. For this, first of all, we have to go for assumed mean. So here I am calculating, here you can see. So first of all, assumed mean. Let assumed mean A, that is equal to here, let us say here 3250. So 3250, and the class width we know already 500, and therefore we can go for the deviation, that is each observation minus 3250, that is 2000 divided by 500, that is -4. So accordingly -3, -2, -1, 0, 1, 2 and 3 will get this step deviation is here continuous frequency distribution with equal class length. First one 1250 minus this, that is 2000. So here 2000 negative divided by 500, that is -4. So for that next -3, -2 and so on. So now let us go for FIUI. So 24 4s are 96, -96, 43s are -120, 33 2s are -66, here 28 1s are -28, then here 0 into 30, 21 1s are, then 16 2s are, and then 7 3s are 21. So here summation of FIUI. So what is the total sum here? We have to go for the calculating the negative total sum and the positive value. So here you will get -235. So -235 is the total sum. Okay. So now therefore we can go for mean, that is H bar is equal to assumed mean plus sigma FIUI divided by sigma Fi multiplied by class width. So substituting the value, H bar is equal to assumed mean is here 3250 plus -235 divided by sigma Fi, that is 200 multiplied by 500. So 0 0 cut, and therefore we will get here mean is equal to 3250 minus, as it is negative 235 5s are divided by 2. So here you will get -1175 divided by 2, and that means here we will get 3250 minus here is 587.50, and therefore the mean is 3250 minus 587.50, that means 2662.50. So this is the mean expenditure. So here the mean average expenditure of all the 200 families is 2662 rupees and 50 paisa. So here mod means we got maximum number of families having monthly expenditure. This maximum number of families are having this monthly expenditure. That means other families are there that may have more than this or less than that, but maximum number of families are having this expenditure, monthly expenditure in rupees. Whereas here average monthly expenditure of the family, that is mean. So we will continue for question number 4.
Thank you for joining us.